Hello, my name is Derek Sutherland, and today I'm going to be talking to you guys about infrastructure agility with Kubernetes. Before we get started, I'm going to do a brief introduction to Shadowsoft, who we are as a company, a little bit of background and history for where this talk came from. We're going to walk through the traditional challenges for operations and how that's led to the evolving change of Kubernetes. We're going to talk about infrastructure agility as a concept, and then putting some of the pieces together to make this potential use case into a real reality. So first, who's Shadowsoft? Where are we from? What do we do? Shadowsoft is a system integrator that was originally founded in 2008. I myself have been here for about 10 years. We have a decade of hands-on experience with Kubernetes. We've used hundreds of certifications across Rancher, AWS, Azure, SUSE-based products, Dynatrace, the list goes kind of on and on. We were primarily found out of the DevOps space, doing a lot of automation work, from configuration management to automated delivery, automated provisioning, CI/CD, etc. But as time kind of grew on and Kubernetes became the de facto standard for container orchestration, we several years ago started leaning more and more in, and that's where our business has been built off the back of. At this point, we do a lot of different services around Kubernetes. We do everything from architectural guidance to application refactoring, backup and storage, disaster recovery. Really what this is about is how do people use Kubernetes? How was it originally intended to be functionally operated? And then what are the things we can do to make Kubernetes more effective when we're doing it from a real productionization perspective? And that goes across every major category you could potentially think of. This includes even adoption strategies. So even if you're new to Kubernetes or you've been using it for a long time, how do you keep the growth going? How do you use it in kind of new and unique ways? And how is it evolving over time? This is accomplished through a number of different things. Primarily, it's through our consulting services team. And then secondarily, we do workshops to help customers kind of stabilize and get used to the idea of what Kubernetes is and how it's going to affect their business. And then we help them build out security profiles and different design paradigms for how the systems are going to scale. We also offer some on-demand training. This is not traditional Kubernetes training where you would think of how do I do a certain thing in Kubernetes. This is more changing the way you organically think about infrastructure and infrastructure automation. So it makes more sense under the Kubernetes context. So instead of looking at infrastructure for what it is, which traditionally has been these long-lived machines, how does shifting to this new model of applications that are moving consistently throughout the environment, how ultimately that's going to impact the way things function and run, how upgrades and updates and security is going to change, etc. So that's really the primary areas where we've played in and why we have a lot of experience in Kubernetes. So again, I'm Derek Sutherland. I am the Director for Technical Services at Shadowsoft. I've been here for, again, about 10 years, but I've done everything that our company has in terms of different hats, with the exceptions of being a salesperson. I have been involved in technical marketing. I have been involved in pre-sales. I've been a consultant for the company. Currently, I oversee kind of the technical delivery from a actual implementation perspective, as well as when we go to do pre-sales or solution design, it usually rolls up to me. That means essentially that when someone's having problems in an engagement, customer success type issues, or if something's not going that well, or even if things are going well and we're just trying to get more efficient, usually when it falls into the technology realm of how we could be doing things better, I try and help facilitate that through conversations with my team and really relying on their skill sets and making them to try and be as successful as humanly possible. A little bit of my background, I have a master's degree in cybersecurity. I have a dual bachelor's in comp sci and comp sec. I come from a technology background, primarily software development out of the federal government. I used to work for the DoD, and I would do things like write different software applications in Java that would do things like single sign-on management, authentication, authorization, and auditing. We even came up with our own injection technique for how to roll these controls out automatically without developer intervention. So it's kind of based on the same principles of how agents work in, say, performance monitoring solutions like Dynatrace and such. So I have a longstanding background in software development, primarily on the object-oriented side. And I've been using Kubernetes for just about as long as the company has. So my first endeavor was within Kubernetes about 10 years ago, and I've worked with it ever since in different capacities. Sometimes for just deploying the environment, sometimes for approaching new concepts and ideas, troubleshooting unique concepts, etc. So with that, I want to talk about some of the traditional challenges companies have with operations in general. This is Kubernetes aside. This is just, boilerplate. What's a problem that everybody's facing right now? So everybody is pretty much trying to do the same thing in terms of some of these major categories. When it comes to disaster recovery and high availability, some people have some automation, but usually it ends up being a very manual process. Even with automation, it's time consuming, it's expensive. And part of the reason for that is because we have all these different hybrid environments that are all built differently. The same comes with cost optimization. Some of you may have heard of the idea of clawback in the cloud. And that's this concept of like workloads have been moved to the cloud, maybe it's getting really expensive and businesses are thinking about bringing it back to being on premise. I kind of see this as like a never-ending game of like, we'll put it in AWS. Oh, it's cheaper in Azure. We'll move it to Azure. Oh, we got to move it back on premise. Oh, we want to go back to the cloud. And this is kind of a never-ending cycle that causes a lot of heartache and pain when it comes to migration, because every move between these different environments traditionally has required refactoring and a tremendous amount of time in how to learn and deploy into these new environments. And even if you built kind of for these different cloud providers, there's still so much difference between the way that they're set up from a layering perspective. You get into really big security and compliance challenges where every time you go to move to a new environment, you have to think about security and even the way you optimize your tooling differently. So why do I think this is the case? In my personal opinion, I think this is because there's never been a unified infrastructure API. Every infrastructure, whether it's VMware on premise, bare metal infrastructure, if it's Azure, AWS, GCP, if it's DigitalOcean, it doesn't really matter. Everyone does their stuff a little bit differently with how they manage networking and storage, etc. Now, AWS may have its own nomenclature, but in general, just the APIs are different. Like the way that you provision things in Azure is just different than the way you provision things in Google or AWS. It doesn't really matter, right? So that's one huge part of it. The other aspect of it is that with environmental costs changing over time, this is becoming a bigger and bigger issue, where at some point you might go, it is cheaper to run on premise. And then at another point you might go, it is cheaper to run in the cloud. We don't really know which is going to be cheaper at any given time. So I think being agile in the way we develop things is really key and important to thinking about what we're going to do with the business. And quite frankly, the idea of lift and shifting is just not feasible given current environmental differences. I mean, again, you can't just take a VM that's in Azure and immediately drop it into AWS. You have to take the actual underlying virtual machine and create a snapshot of it, convert it to something the other cloud understands, upload it, and then get it running again. There's some other ways of handling that. There's some other tools that have developed out there, but that's in the simplest use case. If you start getting more and more married to a different cloud provider, you're using Lambda functions and Kinesis streams and SNS and SQS. Now it becomes harder to start moving things to other cloud providers. And don't get me wrong, I'm not anti-cloud, but what I think I'm pro more is how can we unify things to be more simplistic? Especially so that way security professionals can be really focused on the differences that are to the platform or the way things are built, but not to the different environments that you may end up operating within. So why am I talking about this? And can Kubernetes help solve these problems? And I think the answer traditionally, as always, lies in the details of how we look at Kubernetes and how maybe it's been traditionally used. So Kubernetes originally had two different really basic models for functioning. The first original one, several years ago was, hey, I have dev, I have test, I have pre-prod, I have prod. I want to convert our environments to be Kubernetes based, mostly for the purposes of replatforming. So that way the environments looked kind of similar, which kind of builds on the same idea of what I'm talking about here. We wanted to have a unified way of looking at our workloads in these small use cases. So if something's in pre-prod, it looks exactly the same in prod from networking and et cetera. This then got expanded out to software at the edge, where now instead of maybe 5 or 6 clusters, you might have hundreds. And now the bigger problem becomes how do you manage these at scale? And Rancher is great at helping with that. But what is other ways that you could be using Kubernetes that kind of build on the premises that are foundationally set in the ways we originally talk about it? I think first we got to look at what does Kubernetes provide through a specific lens. First of all, it's a workload and environment management API. The cool thing about that is it's software-defined everything from networking, storage, service discovery, etc. And it doesn't care what the underlying infrastructure is. You could put Kubernetes in AWS, you can put it on premise, you can put it in Azure. It's the same everywhere. And it's built on open standards, which is great. If you look at it from that lens, you can even say that it limits the variability between environments to being only when you install the actual platform itself, and how you can elastically scale the platform in terms of things like adding new nodes. The cool thing is it's even growing now, so you can include VMs as well. Now, granted, that's on premise, but I think there's hope for the future, and maybe some kind of way we could use VMs, maybe not through Kubert, but from some other mechanism where Kubernetes is able to manage an EC2 instance or able to manage an Azure VM. But for the time being, at least, we can deploy, if a cloud has bare metal nodes, we can deploy VMs to that, or we can do nested vert, which is also kind of neat, but not necessarily great for production. But where is Kubernetes going to fall short by itself? And by itself, I mean if you have one single cluster. Well, clusters weren't traditionally designed to scale across multiple data centers. Now, when I say multiple data centers, I don't mean multiple AZs in the same region. I mean different regions in separate clouds, or just separate clouds in the same region. So US East Azure and US East AWS. All these problems could maybe be solved by a single cluster if you use something like Calico with BGP peer networking, but that's not really how Kubernetes was designed, and I don't think it efficiently can be managed that way at scale. But what do you do if you're going to move things to different environments? And is there a better way of leveraging Kubernetes to kind of solve these problems? And I think with additional integrations, yeah, you could do things in a way that's more streamlined and fault tolerant. So this is where the idea of infrastructure agility comes into play. So at the premise of it, I think we have to look at Kubernetes as a unified management API. Daniel Bell once said, technology is like art. It's a soaring exercise of the human imagination. And I think that's the thing we have to keep in mind here is how we use Kubernetes affects the kind of capabilities of which it can give us. So we talked about the first two models of traditional web apps and software at the edge, but I think that third use case is really building on those premises to think about it as a software-defined unified API everywhere, meaning Kubernetes becomes the foundation for how you load your workloads, containers or VMs aside, at least in most situations. Again, if we're talking virtual machines in the cloud, there's a little bit of a limitation. So I don't think we can completely take that into consideration yet, but it's something we can at least look at in the future with nested vert or bare metal in the cloud when it's possible. So just a brief reminder, if we're looking at a Kubernetes cluster, we usually have our control plane / master nodes and our compute nodes. Those are built out usually in terms of one network layout, in terms of what each node can talk to each other. They can talk to the control plane nodes. It's living inside of traditionally one region in a cloud provider. But if we want to expand this out to touching multiple cloud providers, what we would usually do is spin out another Kubernetes cluster. So if we do have two Kubernetes clusters, could we be infrastructure agile? And I think we could do it even without these technologies, and there's multiple ways to skin this cat, but we could start looking at things at least from a disaster recovery model, a cross-site networking model. We can unify things in a way that allow us to be more agile in the way that we use Kubernetes. So with that, I'm presenting three different solutions here, but I think that these three solutions are just three solutions in the space that can facilitate some of these capabilities. And by no means are we married to the merits of what these things are built on, but more about the premises that they stand for. So Avesha in this instance is a provider for a system called KubeSlice. And we're going to get into that, but they're going to provide a functionality that is cross-cluster encryption and network discovery. So we're talking about how do you tunnel between different environments, whether they have an instance of Istio in them or a different service mesh inside of the other cluster, being completely service mesh agnostic, allowing us to ingress traffic no matter where it's coming in from and kind of load balance it across different environments and allow it to funnel through. Secondarily, we're looking at the storage aspect. How can we replicate persistent storage between clusters, doing bidirectional DR replication and things like that? And then thirdly, how can we do intercluster zero trust? And that's where New Vector comes into play as being a really strong security presence in the space, probably the best cross-cluster networking piece that we have available to us from a security piece at this time. So what does Avesha KubeSlice do? KubeSlice's main function is to take different clusters and make them look like they essentially are one sliced up cluster or multiple sliced up clusters that are divided up differently. So if you think of this of having a cluster on premise, a cluster in the cloud or a different cloud or in a private data center, if you install KubeSlice in these different environments, you can link all of them together. And that gives you the unique ability to be able to automatically, through service discovery, to find another workload living in a different cluster by sharing the service exposure across cluster. Secondarily, it also gives you the ability to kind of set up these separated environments, which you can subdivide the clusters up. Because the way it connects these environments is through namespace recognition. So if you have, say, a handful of namespaces in one cluster, a handful of namespaces in another cluster, those, let's say namespace A in cluster 1 and namespace B in cluster 2, can look like they are one single network infrastructure, and the workloads in each side can automatically service discovery, the one on the opposing end. This allows us not only to be decoupled from a service mesh, but it also gives us the ability that if we want to put different pieces of the clusters together, even if we wanted to put the same workload on both sides and have it auto scale independently, you could in theory route traffic to one cluster and then to another in the terms of fault tolerance, DR, etc. Now, in terms of cost optimization, Avesha also offers another tool called Smart Scaler, which is a really compelling horizontal pod autoscaler. The back end of it is a SaaS platform that does reinforced learning on the type of input that's coming in from a network traffic perspective on a given workload, and then helping reconcile what the actual number of pods should be at a given period of time based on load and things like that, in a way that is accurate to the needs of your business rather than using, say, CPU or memory metrics for horizontally pod autoscaling. Now, you could build custom Prometheus metrics and get a little bit something better than memory or CPU, but this gives you the kind of learning that you wish a human was at the steering wheel, so to speak, for making these decisions in real time with your applications. So if you put an application in 2 clusters or you put them in 1 cluster, this will smart scale it, so to speak, in the environment. Now, if you think about it that way, you can have an application live in a slice on cluster 1 and a separate application, or even the same application, live in a slice on cluster 2. And you could, using different load balancing mechanisms, load balance between both clusters. You could have Smart Scaler go, hey, there's no load coming into this cluster, so let's descale that workload down. And hey, there's tons of workloads coming in, let's scale that workload up. So this is going to help you save on cost and be truly more high available. Now, on the storage side of things, what we're looking at is cross-site replication is probably too strong of a word right now. What I would say is a real disaster recovery model that is as close to being synchronous as humanly possible at this juncture. So what we're looking at is a Longhorn instance for software-defined storage that is in one cluster and another Longhorn instance that is in another cluster. Now, traditionally, when you're creating a storage volume in a given cluster, Longhorn will create snapshot replicas of, depending on what you want, those storage volumes in a given cluster. But what if we want to be safe from an infrastructure agility perspective? What if we want to quickly fail over or switch to a new environment? Well, what you can do is you can set up a primary storage cluster in one of your Kubernetes clusters, and then a secondary storage cluster, as I mentioned earlier, in another Kubernetes cluster. With that, you can have a recurring backup job, and this can run relatively quickly, even as short as a minute if you really wanted to take backup snapshots and upload them to an S3 bucket, an NFS store, etc. And in the secondary cluster, you can set up what's called the disaster recovery volume. And that will continually sync to the data that is referenced in the backup repository that the other cluster is pushing to. In doing that, the disaster recovery data volume isn't going to be necessarily usable immediately to the workloads that are downstream. What you would do in a disaster recovery situation is you would wait for an issue to occur in cluster 1, the primary storage cluster, and then at the time of that happening, you would use some automation code like Ansible, or you could use something like Azure DevOps or Jenkins to act as a webhook responser to whatever you want and launch a command, and it could be done with Helm or kubeyaml or, again, some kind of automation tool to spin up your workload in the secondary cluster and immediately attach to that disaster recovery volume once it gets activated. Then the last piece of this puzzle would be NuVector, which, again, I'm sure many people that are at SUSECON know what NuVector is, but for those of you who don't know, it's a complete full-stack security solution covering the supply chain side of things as well as runtime. So it's going to do vulnerability scanning for known CVEs. It's going to do compliancy checking and admission control to make sure that nothing that gets deployed in your environment isn't supposed to get deployed in your environment. And then from a runtime security perspective, it's going to look at the network process and files that are going in, running in the system by looking at what's the payload coming in, kind of like a WAF. It's going to look at what file systems are getting accessed, what ports are going to get opened. And it's also going to look at how are these things getting put together top to bottom. So if you're looking at the way clusters traffic is going from east to west, or even from inter-cluster traffic, it's going to baseline what's considered normal behavior. And then at the point at which something out of the ordinary is occurring, an application is trying to talk to something different than it should, it's going to either send an alert or deny access to that behavior and stop it in flight. This is the only tool that I know in the space that is doing this, and it's a really robust solution that I think can be really compelling for a lot of different customers. So let's talk about this from a visual perspective. Imagine we had 3 Kubernetes clusters. Each had a Longhorn instance deployed to them. One of them, let's just say the one that's in AWS, is the primary Kubernetes cluster. It's running RK2. It's being managed by Rancher. Longhorn's installed there, and it's currently backing up to an S3 volume in AWS, or maybe it's backing to a MinIO instance or an NFS server. There's an application running in that environment. Now, a user goes to request that application, and they'll get load balanced. Maybe you'll have a private load balancer somewhere in the environment that's load balancing these environments, where it's sending all traffic by default to cluster A in AWS. So the traffic goes in, a backup is made of that volume, and when that backup of that volume is made, that's going to then get replicated into your downstream cluster in Azure, as you can see the disk above. Now, when that happens, at the point of this occurring, let's say that app A or cluster A goes offline, you could have automation code react to your environment by listening to either a Prometheus metric, Isinga health check, maybe Dynatrace, depends on what your monitoring solution is, and make a determination that, hey, since we're seeing this application go offline, let's go send a webhook to, again, a Jenkins server, Azure DevOps, code pipeline, whatever, and kick off an automation job to pull that data volume into the new cluster, deploy the new app, and then when the next request comes in from the cluster, the load balancer will notice the cluster A is no longer functioning and send traffic to the remaining cluster, which in this case would be cluster B in Azure. So in essential, that's the idea of infrastructure agility, building a true automated disaster recovery model that allows you to not only keep your systems alive, but also gives you the added benefit of, now that all of your workloads, and this, by the way, is not just for containers again. This could be used for VMs. If you have a VM template in one cloud, or I shouldn't say one cloud, in one bare metal instance, that could be cloud provided or on-premise, and then you have that running in another cloud provider, they'll leverage Longhorn from a storage system. They can be interconnected with KubeSlice as well, and you could set up your load balancer in a very similar way. So I go out and say all this to say is, by leveraging Kubernetes as a unified management API, we can truly become infrastructure agnostic and be truly infrastructure agile, where we're able to deploy things in different environments rather quickly without having to worry about the concerns of what are the differences in each individual environment and how am I going to have to refactor and move things over. Things to consider in the future and areas of improvement: that bidirectional latency and bidirectional performance of storage replication, so synchronous versus asynchronous. That would be something that we could obviously build upon, and we can look at Longhorn to hopefully in the future to hopefully be able to support in some capacity. And then again, mentioning the KubeVirt piece, it will be really interesting to see cloud virtual machines get abstracted into KubeVirt. Maybe that'll happen. I'm hoping I'm just generating the right ideas and putting the right energy into the atmosphere that this could actually become something we see in the future. The last thing I'll say is innovation requires thinking outside the box. And Dan Brown put it best that knowledge is a tool, and like all tools, its impact is in the hands of the user. Thank you. And thank you for having me here today. I really appreciate you guys standing and listening for my talk.